Okay, so here's another video over the second integration sheet that we had for homework, and this is problem number 3, and we're still trying to verify that the equation that they've given us is actually correct by using differentiation. And that equation is telling us that whenever we integrate cosine cubed of x dx, that should be equal to sine of x minus 1/3 sine cubed x plus a constant. So if you go ahead and set up your f of x, as being equal to sine of x minus 1/3 sine cubed of x. And if you wanted to, just to help you kind of keep things straight in your head, you can write sine cubed of x like this as well. They're the same thing. Just this way it might make it a little bit more clear in your head to use the power rule. And that is still going to be plus or constant. Alright, so whenever we take the derivative, we're going to have f prime of x is equal to the derivative of sine x is just cosine x minus 1/3 that whole part 1/3 sine cubed x. Since 1/3 is a constant, we keep the constant, and that's going to be times. We bring the power down, and in this case the power, we're cubing it, so it's going to be times 3. We bring the power down, and then we keep what's inside, subtract 1 from the power, and then we multiply that times the derivative of what's inside. And so, like we said before, the derivative of sine is cosine, and then our constant, the derivative of constant is 0, and all of that is with respect to dx. Alright, so now we clean that up a little bit. We're going to have cosine x minus 3/3, which is just going to give us 1. So we're going to have sine squared x, and like I said before, if you have the power outside of it, sine squared x, you can write it like this as well, and that is going to be multiplied by cosine x, and all that's with respect to dx. Alright, so if you remember from your pre-calc class, sine squared x is equal to 1 minus cosine squared of x. And that's because whenever you have the unit circle, cosine squared plus sine squared is equal to 1. If you want sine squared by itself, you just subtract cosine squared from both sides, and so sine squared x is equal to 1 minus cosine squared x. So that's just a handy little tidbit that's going to help us out on this equation. So that's going to be equal to cosine x minus, and we said that sine squared x is just 1 minus cosine squared x, and that's times cosine x. Okay, and that's still dx. So now we're going to go to the next slide. Alright, so that brings us to here. if you remember, we said that this value was just sine squared x. So technically, let's see, this whole thing is one term, and this is one term. So we can actually pull out a cosine x from the terms, and that's going to leave us with 1 minus our 1 minus cosine squared of x. And on the inside, you can go ahead and change those signs. So it's going to be, that's going to be plus -1 plus cosine. And as you can see, these two are just going to cancel each other out. Let's see, I'll just rewrite it here. We had 1 plus -1. And that's just because we changed the sign. So that's going to leave us with cosine x. Oh yeah, our dx is still out here. Cosine x times, our 1's will cancel, and we'll just leave us with cosine squared x on the inside, which is equal to cosine cubed of x dx. And if you remember, that was what our original equation was asking us to do, was to prove that the integral of cosine cubed of x dx was equal to sine of x minus 1/3 sine cubed x plus a constant. And that was by, we just proved that by taking the derivative of that. And those two right there are indeed equal as far as our f of x. So we just proved another one.